Thank you for the invitation to present to you at the 4th National Rangeland Forum of Mongolia. My name is Brandon Bestelmeyer. I'm the research leader of the USDA Jornada experimental range in Las Cruces, New Mexico in the United States. And I've had the honor and the pleasure of working with Green Gold and with the National Federation of Pasture Users Groups of Herders for several years. And I especially want to thank Dr. Amgalan for the invitation to participate in this forum. And I deeply regret not being able to be there in person to see you all and to see some of my old friends. So I'm going to talk about the science that is needed for sustaining rangeland ecosystem services in a changing world, and in particular, the infrastructure that Mongolia has at its disposal for supporting an ecosystem services perspective in rangelands. And ecosystem services was really a revolutionary concept that started in the 1980s and really has become an important framework in which to view ecosystems over the last 2 decades that categorizes the benefits that people receive from ecosystems using 4 different categories. The first is provisioning services, the products from ecosystems that are typically emphasized in agricultural systems. In the case of Mongolia, that would include meat, wool, and firewood from forest patches. The regulating services, which are other benefits from ecosystem processes that are received by people, such as dust control within a rangeland that has high grass cover, climate regulation and carbon storage that influences atmospheric carbon dioxide and greenhouse gas concentrations, and then water quantity and water quality provided in well-managed systems. The third category is cultural services, and these are the benefits to human condition from ecosystems, including knowledge that enriches life, traditions that are carried out in rangelands and other agricultural systems, and recreation and tourism opportunities, which of course can be commodified. And underpinning all of these are supporting services that are supported by healthy ecosystem states and processes that are ultimately needed to support all of the services above, including soil formation and soil stability, primary productivity, as well as plant and animal diversity. It's also well known that agriculture can produce trade-offs in ecosystem services. For example, in a natural system, provisioning services, the very top petal of the diagram, may not be emphasized, but that system may be very strong in supporting, regulating, and cultural services, whereas an intensive cropland on the right may have a very strong production of provisioning services, but relatively weak contributions to cultural regulating and supporting services. Rangelands, on the other hand, are an exception to this generalization in supporting multiple services at the same time. A healthy rangeland can sustain the production of wool and meat provisioning services. It can experience low erosion rates and high carbon storage, which are regulating services, and can be beautiful, healthy land that is desired for recreation as well as tourism, which are cultural services. It's known that an overemphasis on provisioning services in the short term can lead to the loss of supporting, and then eventually most other services, including provisioning services, in the long term. So a very small economic gain in the short term can lead to long-term consequences with large effects for other ecosystem services, and then eventually also provisioning services. And this occurs through the process of land degradation, in which productivity and diversity of systems are reduced. There are changes in soil properties such as bulk density, infiltration rates, runoff and erosion, and then, of course, carbon sequestration potential that are all impacted by land degradation. And this is a very significant change in supporting services as well as other ecosystem services. So I'm going to describe now 7 principles for managing and sustaining ecosystem services, beginning, of course, with supporting services, but then including all the other services. The first principle is that expectations for the magnitude of ecosystem services need to be based on land potential. There are certain parts of a landscape that are naturally more productive, and then areas that are naturally less productive and therefore less capable of supporting provisioning as well as other services. In Mongolia, ecological site spatial data that are managed by the Agency of Land Management, Geodesy, and Cartography are able to provide guidance on the potential ecosystem services and how they vary within a landscape. The second principle is that the loss of supporting services has clear indicators and that restoration is usually possible over time. I think this is the primary message from monitoring data interpreted with respect to state and transition models that provide guidance not only for detecting the loss of ecosystem services through changes in productivity as well as key indicator species and bare ground cover, but also indicators for the requirements needed to restore ecosystem services and to maintain supporting services before they cross irreversible thresholds. The third principle is that both local as well as distant stakeholders may have rights to and interests in different ecosystem services. So in this case, an example from the United States, a rancher may have rights to forage resources because he owns or he leases the land, but the city dweller that may be adjacent to that rangeland has rights to clean air and clean water, for example. So ecosystem service management goals should be broad-based and inclusive. And this leads to the fourth principle, which is that management of ecosystem services must be community-based and incorporate varying values. Once again, this is something that Green Gold and the National Federation of Pasture User Groups has accomplished very successfully in Mongolia by providing a mechanism for herders and local and national government to co-manage ecosystem services with respect to a variety of perspectives. The fifth principle is the how, that resilience-based management can sustain and restore ecosystem services through first the organization of herder communities, understanding spatial information about, for example, grazing boundaries and restoration needs within a particular management area, the establishment of agreements as well as specific grazing plans to maintain or restore ecosystem health, the implementation of those plans successfully, and then ultimately the monitoring of both management impacts that can be used to update grazing plans and also provides information to consumers that may be interested in knowing that land is being managed properly, and then long-term vegetation monitoring to see these changes carry out over the long term, which is going to be important for national reporting of trends to the public. This process, known as resilience-based management, has been inclusive and has been broadly implemented in Mongolia, and as I'm sure you'll see at this conference, has been quite successful. The sixth principle is that stakeholders with few rights but deep interests in regulating and cultural ecosystem services are often willing to pay for them, and this is well known as the payment for ecosystem services scheme, in which upstream ecosystem service providers provide services to downstream ecosystem service users in the form of water quality, water quantity, carbon capture, and other services, and that those downstream users may provide payments, materials, technical assistance to support the upstream ecosystem service providers. So this is reflected in Mongolia as well as the United States in government support for rangeland conservation practices and government investments in co-managing rangelands, as well as in the market through price premiums that are paid by consumers for products that are linked to conservation practices that are known to enhance non-market services. The seventh principle, and the last one I'll talk about, is that measurable indicators and trusted tracking mechanisms are essential to market non-commodity services. It is important to recognize that the Mongolian government and the Agency of Land Management, Geodesy, and Cartography, as well as NAMM, have provided high-quality rangeland monitoring data that supports these indicators, and that these monitoring data create value in non-commodity services because they provide a means to quantify their value. Regulating service of particular interest at the present time is carbon storage. It's known that well-managed natural rangelands have been carbon sinks at a global level. And as we can see in this diagram, there are many routes for the loss of greenhouse gases to the atmosphere, but there's only one route for the transference of greenhouse gases into carbon in plants and soil, and that's through photosynthesis and the yellow blinking arrow there. The problem is that climate change and land use are eroding the ability of rangelands to store carbon and to regulate, to the extent rangelands can, greenhouse gases. And an important question that you may be thinking about is, are Mongolian rangelands storing carbon? Well, it's going to depend, and fortunately, you have the capacity to understand these requirements. First, it depends on the ecological site, whether, for example, it is in a very productive meadow or on an upland with thinner soils and naturally lower productivity. It depends upon the ecological state, whether it's in a reference condition or if it's in an eroding state, for example. It also depends upon climate, whether you're in the forest steppe or whether you're in the Gobi Desert, where the vegetation can be naturally a source or a sink, depending upon the weather. It's really important to understand the magnitude of the sink and then the magnitude of the source. In meadows, for example, that go from a reference condition to an eroding state, you may be shifting from a large sink to a large source. And then in those more, those uplands on thinner soils, there may be moderate sinks to moderate sources. It's going to be really important to quantify these differences to fully account for carbon sequestration as well as other ecosystem services, and monitoring data that are linked to ecological states and process models can provide that information. For example, in the United States, one of the approaches that we're using is to conduct measurements in different ecological states of particular processes such as wind erosion, water erosion, and soil carbon sequestration at a number of intensive measurement sites distributed across different ecoregions and on different soils, and then using models and then connecting those models to rangeland monitoring databases, such as the Landscape Data Commons that we house all of our monitoring data in. We can produce local and national estimates of different ecosystem services, wind erosion, soil carbon sequestration, and potentially wildlife habitat quality. Mongolia has the monitoring infrastructure in place to understand how ecosystem services are changing. So I'll conclude by saying that healthy rangelands support more than just livestock production. They support climate regulation for the global community, wildlife, clean air, and beauty for all Mongolians, and climate resilience for current and future herders. The challenge before us in the next phase is to measure and account for multiple ecosystem services and find ways for herders to receive credit and benefits for enhancing that bundle of services. So thank you again for the ability to participate in your conference, and I wish you a good rest of the conference. Thank you.